Hi everyone, this is the last part 4 video for channel and floodplain 2D modeling with HEC-RAS. In this video, I will suggest alternative cases of simulation based on previously developed unsteady flow plan. So you can see how the model performs and check the results differences with time step, grid cell size, and computation mesh with break lines. So before starting to make different scenarios and options based on this previous developed unsteady flow plan, we need to check the working directory. So the previous part 3 video, you can only see the unchecked the files, but after simulation of this unsteady flow, many different these files newly created on this working directory. Okay. So now I will develop different time step based simulations. So you need to go to this button. So perform on unsteady flow simulation. So click, and then you can see this unsteady flow analysis editor. So last time we developed this 500 feet 1 minute this computation time interval based simulation. So in this case, I will just shift from 1 minute to 5 minutes, okay? And then you need to change this combo box with 5 minutes. All the other things would be the same. So in here, you need to save plan as. So in here, you can also change with this 5 minutes. Okay, so just click OK. And then again, we can find this the box with the short identifier. So 500 feet, 5 minutes. Okay, just we developed. I will also make another plan. So in this case, I will make 30 seconds based the simulation plan, and also you need to change this one. So 30 seconds. Okay. So again, you need to go to save plan as. Then in here, you need to change 30 seconds. Okay. So again, this one. Short plan identifier. So click OK. So now we developed 3 different time step based scenarios. So need to check the working directory. So in here you can find new plan file. These two P extension files are generated. Okay, so we safely made this kind of unsteady flow different options. So now we need to learn this one, the 30-second first. So before that, we need to calculation option and tolerances. So need to check with these 20 hours. Okay, just click OK and compute. This would be 30 seconds based time step simulation. You can see. So now almost done with the simulation with 30 seconds interval. So it takes some more time than the 3 minutes. Around 4 minutes took all the simulation for this unsteady flow. Please close and check this another plan. Open. So before close this simulated plan, so save yes, and then you can find this one. So I will bring this 5-minute interval time step based simulation. So in here also you need to click this compute button. So it would take more short time than the others because this time step is more longer than the previously developed model simulations. So now we are under processing with 5-minute time step based simulation. Okay, almost done. Okay, we finished it. So this would be only required 43 seconds. So very quick than the other two computations. Okay, so please close this one. So now we've done different time step based unsteady flow analysis. So just file, go to and save plan, and then just close. And then now I will create another different grid cell size based simulation. So in this case, go to this view and edit geometric data button, and then go to file, save geometry data as with different titles. In this case, I will just use 2050 pit grid cell size. So in here 2050 pits. Okay, and just click OK, and then go to this 2D flow area edit button. So you can see this the 2D flow area editor, and then one more click this one, generate computation points on regular interval with all black lines button. Then you can find this box as well. In here you can change the spacing for this the 2D mesh. So 250 spacing I will use. So just click generate points in 2D flow area. So click yes. So now we finished the different grid generation. Okay, so just click OK, and then save this the newly created geometry data. So yeah, you need to close this data. After that, go to this the unsteady flow editor as well, unsteady flow analysis editor. So you can see now we just shift from 500 feet to 250 feet. And then all the others are same. So in here I will make 250 feet and just use 1 minute interval. And then all the others are same, and you can change it in here with 1 minute. Okay, so you need to save plan with 250. Change this title and just click OK. So again, this one, just click OK. After that, just click compute. So now we simulate different grid cell size based simulation from 500 feet to 250 feet simulation with 1 minute interval, the time step. Okay, again you can easily understand this 250 feet grid cell based simulation required more time because the number of cell size. So you can easily identify the required time to computation would be increased than the 500 pit 1 minute interval simulation case. Okay, so now we are almost done to simulate all the process. Yes, actually we finished this simulation. All the required time was there around 15 minutes. So you can understand why this kind of the more minutes took for this simulation. Okay, so in this case just close this button and one more save this frame for 250 pits grid cell size and 1 minute interval simulation. So also close. Okay, so lastly I will add one more rabbit things with the break line. So in this case you need to open geometric data editor first and then just open this initial the geometry with 500 bits. Okay, and then I will use this one with the rabbit things, I mean the break line I will use. So save geometry data as with this the initial to the rabbit things. Okay, so LEVEE. So I will give this new title and just click OK to develop. So I just made one the geometric data folder levy. So just save again and then just open this RAS mapper. Okay, so you can find three different geometries on here. So how about make big screen? After that, you can see this initial and 250 geometry as well. And then you can see this Revit. So uncheck this initial and also this 2D flow area again. And then how about this 250 pits? It's okay, and just Revit. Then you can check this the 2D flow area with this the perimeters. Okay, in this point you need to uncheck this result as well as this terrain, but terrain is okay. So in here I will make one levy for with this line. Okay, this levy things with the break line. So in here you can find this break line and then just click break line, right click to edit geometry. This is the break line. So make zoom for this these things and just make some levy on here along this line. So maybe we can have some different simulation result with this levy. So double click and then just give this break line just default. After that, right click and this one enforce all break lines, and then you can find this the grid cell would be different with the lightly generated. So how about check this computation point? So after that you need to check this one to find some possible errors for that. So I think it is okay to use. Okay, so again this the 2D flow area, right click and zoom to layer, and again right click, stop editing to save this the break line. Okay, just yes. After that, just save this the last mapper, and then we just created this Revit the geometry files. Okay, so just close this last mapper. After that, go to this the Unsteady flow analysis editor. So now we are select this Revit for geometry file, and then this computation interval would be 1 minute. So we need to give a short name with Revit 1 minute. Okay. So and then file save plan as this one would be just Revit 1 minute. So LEVE 1 minute. Okay, just click OK. Again, this box, click OK, and then we just developed this Revit 1 minute simulation case for this unsteady flow analysis. So just compute. Then you can see status window for this computation with the Revit with 1 minute interval case for the time step. Again, almost done. Now we use the different grid cell size. Now we've done different 2D mesh with the black line. So around 3 minutes it took. So we need to close this button and then just save this plan again. Then close this one. So in this point, we need to check our directory folder. So you can see many files are generated with the different plan and different simulation result. Okay, so you can check all your newly generated file in your working directory. Okay, so open RAS map with this icon and then make big screen. So we just finished this Revit things to simulate. So uncheck this Revit things. We don't need any geometry file at this point. So again, this geometry just collapse. We need to check the result. So go to result and then we can find our developed and simulated the scenarios on here. So you can check 500 feet 1 minute, 500 feet 5 minutes, and 500 feet 30 seconds, and 250 feet and 1 minute, and Revit 1 minute. Okay. So now you can compare with these depth things. So check this 500 feet 1 minute, and then check this 500 feet 5 minute depths. Okay, so go to this 1 and just click this animation button. After that, you can compare the very exactly required time. So I think you don't need to check at this point these steps. So now we can see these steps for this scenario. So now we check the very deep the water depths like this one. So this would be 3rd January 1999. There 2 a.m. So we need to check these steps as well, and then go to the same time for the 3rd January 2 a.m. So now we can compare. Okay, two different scenarios. like this one, 1 minute time step and 5 minute time step. Okay, so like this one, you can compare all the other things. So this would be baseline. So 500 feet 1 minute interval time step you can use as a baseline, and then you can compare all these different things with my demonstration things. Okay, so in this case you can find not much differences, but in here so you can find, so we can make zoom on here and then check with this one. So again, not much differences you can find, only this point. Okay, so this was just different time step based comparisons. Okay, so go to this geometry terrain and zoom to layer. Okay, this ends all I prepared HECRAS two-dimensional modeling works with 8 successive videos for 2 different tutorials. I hope my provided these tutorials can help to understand all the basics for the use of HECRAS and your future development and simulation of the actual HECRAS modeling work. Thank you for watching.